There are two different kinds of word problems. Easy word problems and hard word problems. I would call this one an easy word problem because they give you the equation. You didn't have to figure out the equation from the context. So what's happening is a person's on a cliff. Here we can draw a cliff. Woo, that's scary looking. Here's our person. They're on the cliff. They got one long arm, one short arm. Okay. They're throwing a stone up in the air. It happens to be a blue stone. There it is. They're getting ready. They're winding up. They throw the stone up in the air. It comes down. Boop, boop, boop. Or what's down below? Down below is water. Oh, we got to draw the water. Here's our stone. There's a stone throwing into the water. It would make this kind of a shape as it travels. Whoa, it's a tidal wave. Yeah, that's kind of scary. There we go. There's our little stone. That's the shape. And they give us the equation. The approximate height h above the water after t seconds is modeled by the following formula. So you have to take into account some important words in a question like this. They're defining what h is. H is how much above the water it is in meters. And they're defining what t is. T is seconds. So at time equals 0, where's the stone? Still in the guy's hand, right here. Eh? Whoop, whoop. That's not the stone. I'm trying to grab, there's the stone. Right, time 0, it's in his hand. He throws it, and as time goes, that thing travels along the pathway and eventually hits the water. You're splash. Right? And that's what's going to happen. Okay? When will that stone hit that water and make a splash? That is a pretty looking splash. Yeah, it's beautiful. So this is a... Yeah, it is still recording. So here we go. It's a big rock. So the question, we want to find when. So what variable are we trying to solve for? T. We want to find time. Okay? We want to find time. What do we know? Do we know what h is? Yes, we do. No. We want to find it when it hits the water. Yes, we do. The height of the stone when it hits the water is? 55. No. It's up here at 55. How high above the water is it when it hits the water? 0. So now our equation becomes 0 equals 55 plus 30t minus 5t squared. And we can solve this with completing the square. First of all, I'm going to write the equals 0 on this side. I'm going to move everything over to this side. So I'm going to add, subtract 30t, subtract 55. Is everybody okay with that, just moving it over to the other side by adding and subtracting? Then with completing the square, we need to have an x squared all by itself. Yeah. It doesn't matter which side it's on. But we'd also want to, because in this form, the t squared's on the far right, we're used to having our x squared on the far left, so you could rearrange it so that it works out that way. Now I'm going to divide everything by 5. And we get t squared minus 6t minus 11 equals 0. Because I divided everything by 5. I can't factor this one. Normally this would be one that you look at and say, ooh, I want to try to factor. But the only way it would be 11 and 1, and that will never make 6 as an inside one. So we'll go to our completing the square, which means get these two by themselves on one side, add 11 to both sides, and have our space. What number is going to be in the space? 9. Divide by 2 and square. Add 9 to both sides, and you'll get t minus 3 squared equals 20. Square root both sides, you'll get t minus 3 equals plus or minus the square root of 20. Add 3 to both sides, and you get 3 equals 3 plus or minus the square root of 20. Now there's two answers here. One is 3 plus the square root of 20, and one is 3 minus the square root of 20. And if you go to your calculator and actually calculate what those are equal to, we try what is 3 plus the square root of 20 to get a decimal answer. We get 7.47 seconds. If we do t minus or 3 minus the square root of 20, we get negative 1.5 seconds. Now this is a word problem, and in this one only one of these answers makes sense. I threw a stone off the edge of a cliff, and 1.5 seconds before I threw it, it hit the water. Yeah, this one doesn't make sense. So our only answer is this one. That 1.5 seconds. So we go back to our picture here. Maybe it's a heavier rock, so I'll draw a bigger one here. Ooh, that looks like a nasty heavy rock. Starts here, and 1.5 seconds before you threw it, it jumped from the water into your hand and then fell in. Splash. Okay. Perfect. Whoa! We're all going to die. Hey, question 6 and 7.